What's up everyone, and welcome to another Rust electrical tutorial. I'm Nicish, and today we're going to do another industrial crafting video. This time a fully automated drop and go electric smelting build. I've got a power bank set up over here to power everything. I'll leave a link for that if you'd like to know how and why I use this. Otherwise, let's go ahead and get started. I'm going to start by just giving you a demonstration of how this works. And so the idea here is that I've got a depo box that I can dump whatever I've set this up to smelt. Once it's gonna automatically pull those items in to smelt them, turn on, smelt everything, transport everything out once it's done smelting into this box, and then it's gonna sort everything itself into these two boxes. That's just kind of a little bonus piece here, but you could stop here if you wanted. But the idea is that it's gonna turn these on themselves, smelt everything, turn them off when the three are empty for each group, the red, blue, and yellow group, and I'll explain that in a minute. And it's fully automated, so let's go ahead and give it a shot. So if I were to put these in here, I've got it set up for metal ore and sulfur ore. It's going to draw those in on its own, and it's going to smelt them. Obviously, it turned on the furnaces itself. We'll talk about how it is. I do that when we get to the electrical wiring up section of this video. But it's going to go ahead and just cook all this, and as it's cooking it, it's automatically, these ones here are pulling out the products when they're done, depositing them into this box. And then from here, they're being sorted into a shards box and a sulfur box. So of course, whatever you're smelting or however you're sorting could be different, but the idea is essentially the same. So you can see that they've all shut off because they're finished. They're now empty. So now we should have 90 shards in here and 90 sulfur in here, and we do. It's exactly what we wanted. All right, so let's start with the setting up the industrial crafting stuff, the industrial items. Obviously, I have my electric furnaces here. I have chosen to do groups of 3. Like I said, a red, a blue, and a yellow group. I've just color-coded them to try and help you see how I did this. But you don't have to do this. But for this video, I just did this because I thought this is a nice amount of them if you were trying to really get some stuff cooked off. So if you can do less or more, you just have to do some adjustments to how much power you send. So each furnace, of course, has a storage adapter attached to it. So I'll go over just this red group, but the build for this is exactly the same for the blue and the yellow. So I have a storage adapter on each one. The output of the storage adapter here, the industrial out, is running to one of the 3 ins, it doesn't matter which one, of this combiner. Each one of them runs the combiner, so I have 3 outputs from the furnace combined into 1 output. Now coming on the input side of this, it's the same exact thing, just the input side. I've got the industrial in running from the industrial out of a splitter, the industrial splitter, and I do that to each furnace. So I have 1 line in, it splits into 3 for the 3 furnaces, and they combine back into a single line again as they exit. And it's the exact same on every single one. The input on that industrial splitter is of course coming from the industrial output from the conveyor here to bring the items from this box into that. And so I've just repeated that 3 times for these things, so you can kind of think of this as like one component, and I've just done it 3 times. The input to the actual box here, so I have this dump, the drop and go box, I guess you can call it, and the output of that is running to this storage adapter is this black pipe, and that's running to the input on this splitter up here, and then that splitter is coming off to the input of each of the 3 conveyors here. So essentially what I'm doing is I'm taking items from here, I'm bringing them up, and then I'm breaking them up between the three red, yellow, and blue groups. And I've set up each conveyor. So if I hold E on PC because it's powered, I've set each one to take metal ore and sulfur ore with nothing on the min and max because I don't care. I just want it to pull anything and everything that it sees in this box, no matter what. So we don't care. We don't have to set any values. I've just set that, and each of these are exactly the same. So if you were trying to do something else, you could have one of these be for, you could do sulfur and high qual or something, or whatever you want to do. I've just set it up to be the same across so that I can cook off as much of the metal ore and sulfur ore at once as I can by breaking it up evenly into 9 furnaces here, electric furnaces. So that's the input side. again, out of the input box into a splitter. That splits up into 3, goes to each of the conveyors. The conveyors then go to a new splitter. That splits it up into new 3 into the furnaces. That comes back together. And then the output of these, so you can see each one has that combiner, is the output of those is coming up here. You can just follow the color. So we'll follow the red one to another conveyor. And this one is the one that's pulling whatever is cooked. So if we follow the yellow one around, this is the yellow one. It's set to the same exact thing, except I'm doing the fragments and the sulfur. So now I'm telling it to look for the cooked items rather than the ore. So the 3 above the electric furnaces are set to the ore itself, and the 3 output ones here are set to whatever they would be cooking. In this case, it's fragments and sulfur. So pretty simple there. Again, no values. I'm just telling it, hey, if you see it, grab it, because I don't care. They have this, they basically sort of, they cycle and they check for what they can pull every so often. So it doesn't matter. You don't have to like try and account for a furnace still having something in it and it prematurely shutting off. So no values there. You can just set it up to be in and out. And of course, the output of these, each one is running down to one of the inputs on this combiner here. And that then is coming out of that into this box here. And you could terminate here if you wanted. You don't have to keep going. But this box represents the end of the actual circuit. So that's the build as far as the smelting build goes. As far as the sorter, it's very, very simple. All I did was take the industrial out, put that into the in of a splitter, and then 2 of those outputs I ran to 2 conveyors up here, and I just told this conveyor to only pull fragments, and I told this conveyor to only pull sulfur. Again, no values on the min and max because we don't care. We just want it to cook it, move it, and sort it. Again, this is optional, and it's a single power. So we'll talk about that here in a minute. So that's it for that. If you know, it might seem a little intense, but really you're just splitting up and then combining a bunch of stuff from one box and then back to another box. That's all I really did there. So now we're going to go ahead and move on to the electrical part of this. And I've tried to group this as best as I could. So we're going to start with each group. And I'm going to go ahead and just go over, like, say, the red group here first, and we'll explain how it is. So as far as power goes, the only things that we have to power are the conveyors and the electric furnaces. So the furnaces are these lines here. And so what I've done is I've got, to power each furnace, you need 3 volts. You need to send 3 volts. And so I've set it up where each one of these is running 3 here. So this is the main splitter. I've got 4 splitters. 3 of them, I've color coded them again to try and make it easy to follow, but you can just see the band. So this one here is the red. So that's running over to the red group over here. And each one of these lines is simply just running behind there and ends up at this power in. It's kind of hard to, there it is, power in. It's just going there. There's 3 going to it. And that's it. So I sent back here, I've got it's this blue line here. You'll see I've got 31, and so I've got a power block here, and I'm just, this is coming off the battery here to the first branch, and then I just daisy chained 3 branches after it. So it's just this one to this one to this one to this one. So it's power out to this one, power out to this one, power out to this one. Just daisy chain them so that I can have my branch outs to set my values. So as far as powering the ovens here, the furnaces here, I've just set this to 31 and ran the blue line out to the top of this one here, 31. And the reason it's 31, because I need 3 coming out of each one of these. There's 9 furnaces, so 9 times 3 is 27, and then you count the switches for what they require. So 28, 29, 30, and 31. That gives you your 31 here, which will, after this is, each one of these is powering one of these, you end up with 3 coming out here, and then I've just run them to their furnaces. Pretty simple. The other thing you have to power is the conveyors. And now, because this isn't like a security thing or doors, I've talked about that before, you can just, the conveyors have a power in and they have a pass through, which is right there. And they have a pass through. So you can just run these off of each other. So that's what I've done. This is the first one, second one, third one, and then it goes from the bottom 4, 5, 6. And so what I did was from here, and it's just this blue line right here, I've got this set to 6. So from this branch out, I ran from the branch out, this blue line, this like light blue line here. And it's running to, you can see it on the left of the red. That's just running all the way down here and up into the power of this first conveyor right here. So I've got 6 arriving here, and then the pass through of this one is running to the input on this one. Its pass through is running to the input on this one. Its pass through is running to the input on this bottom one here, right there. Its pass through comes out here and comes up to the input of this one. Same thing here to that one. So I've just daisy chained them together, and because there's 6 of them, I needed 6 coming out of here. So that's why I set my branch to 6. And so that's it. That's how I power it. They only need one volt each, and so setting 6 is more than enough. Now these two up here I powered separately just because they weren't part of the main thing. So that's this. Let's see, what color is that? Green. So I've got this green one. It's 2 because I have so the green is running out of that branch to the input on this one, the power in. It's out is just, I just ran it nicely so it looked cool. But it's running to the out of this one's running to the input on this one, and that's all you need. And so that powers everything. I mean, it's not actually a ton as far as the components go, and then but that keeps everything running. Everything can stay on. You don't have to mess with whether these are on or off. Just turn them on and leave them on. That's the way it's designed. And so that's powering stuff. The next part is what got a little tricky, and so I'm going to try and explain this as clearly as I can. But what I needed was, you know, each of these conveyors has 2 outputs, has a filter pass and a filter fail. If it has, so you know, right now it has these filters. So I've got metal ore and sulfur, which means that if it detects, you know, if it can convey stuff out of this box that is those items, when it's conveying those items, it'll send a reference volt out of this filter pass, meaning it is passing the filtered items you set it to. Now, if those aren't there, if it can't pass the items that you've set the filters to, it'll send a reference volt out of the filter fail. Now, on these 3 that are above the furnaces, I'm not using the filter fail because I only want the pass to send out a reference volt if it can pull something out of here, which is how I'm turning these on. And so right now you'll notice that these 3 AND switches are all lit up because these 3 AND switches are associated with the off cycle of everything, whereas this block up here, these 3 AND switches and these 3 splitters are associated with turning them on. And so how that works is I use an AND switch because this one output here, so I have a filter fail, it's sending out 1. That's only enough to turn on 1 furnace because I can only send that to one thing. It's only 1 volt. I need 3 volts. So what I did was I ran that filter fail on these 3, the furnace 3. That runs up, so we have this, see this red line here for the red group. From the filter fail over here, we have the blue running this way. Let's see if I can make that. There we go. We have the blue running up to that group, and we have the yellow filter fail right here. That's running out of the filter fail up and over to here. So you have the 3 lines, the red, the blue, and the yellow, and those are all running to one of the inputs, doesn't matter which one, on these AND switches. And the reason I did that was when this sends out the reference volt, so when this thing sends out its volt, it's gonna power, because the AND switch works by, it requires power at both inputs, and it's gonna pass the greater of the 2. So by sending the reference volt to one side of the AND switch, it powers the AND switch for you and allows you to send exactly what you need on the other side without considering the power needed for this, because it is powered by this other side. So I'm sending 4, which are live. The A sides each have 4 volts coming to them because I need 4 volts for each one of these splitters, because I need each one of these to send out 1 volt every time they're powered to turn on the furnace. And so the outputs of these 3 outputs here, each one are running to the turn on input. So there it is. That turn on input is coming from one of those 3, doesn't matter which one. And the other 2, the same thing. So the other 2 are running to the turn on input here, and the final one's the turn on input here. So this splitter is running the turn ons of these 3. This splitter is running the turn-ons of the blue, these three, and this splitter is running all to the turn-ons of the yellow furnaces over here. And so so that they turn on, I have the filter fail running to the other side of these AND switches, and I'm sending 4, and that's what these are. These are just powered blocks basically, so that this power here, you know, each one of these is coming off of here. I've got 13 coming out of each output here. And so, because what I need is, I need 13 to arrive here, because from here, I have to send 4 out of each of these. So 4 times 3 is 12. I need 1 for this, so 13 total. I've done that twice, because this whole setup is the turn off block, and it's the same idea. It's just hooked up to the other input, and we'll go over that. But this block here, this here, is coming off of one of these. Doesn't matter, they're both the same. And it has 13 in, and each, so it cuts up the remaining 12 into 3 outs. So I have 4, 4, and 4. Those 4, 4, and 4 are running to the input A side of each one of these AND switches. The B side is coming off of the filter fail of each of these conveyors. That's the B side. And then the outputs, the yellow output is running to the yellow splitter, which is running to the yellow furnace group there. The blue, of course, the same thing to the blue splitter. And so when it receives that reference volt, now you have power at both. It's going to pass that 4, and you need 4 here because this needs 1, and then you have 1 coming out of each of these for that moment, and that turns on the furnace. That's how that works. So I'm using the AND switch to amplify, essentially, this reference filter pass volt that's going to turn on. It amplifies that 1 into 3 is essentially what this does. That's all that's doing. And the same thing for when it turns off. You know, whereas on these we're not using the filter fail because I don't care about, you know, you can see it's active because it's trying to pass something, but it can't find anything. But I don't want it to turn off when this then this is empty. I want these to turn off when they are empty. So what I've done is on these output ones, this side, I'm now no longer using the filter pass. I'm only using the filter fail. So it's the opposite of those 3. So the filter fail on these ones, it's the same thing. I've got the 3 lines. We've got the red, the blue, and the yellow, and that's this little colorful band here. It runs all the way across to these AND switches to the B side. Exact same thing. But instead of the filter pass on these 3 going to these, it's the filter fail on these 3 going to one of each input B. Again, doesn't matter what side, but that's those 3 coming back in. And again, same thing. I have a power block here, 13 coming out, 13 arriving here, which means I have 4, 4, and 4, which is what I need at the other side of my AND switch, so that when this filter fail goes off, because remember, these are what's emptying the furnaces. So once they can no longer detect anything, so once, you know, say this red or this yellow one here, once the last furnace of these 3, whichever one it is empty, it's going to send out a filter fail because it can't detect anything, it can't pass anything anymore. And once it does that, that's going to activate this AND switch, which is going to activate, it's going to pass power through this splitter and result in 1 coming out of each of these, which are currently active because these are empty. So that filter fail over there is actually active. You'll see it says 1 coming out of each one. And so that's why these AND switches are green and green on both sides, because they are currently receiving power here. So it's passing 4. So you got 4 coming out here, 4 arriving here. It uses 1, it cuts up the remaining 3 into 1, 1, and 1. And each one of those, say if we trace these 3 yellow ones, they're banded together just to try and make this look a little easier. But these 3 yellow ones come together and they run to each one of these furnaces on the turn off. So that's where these are going. So this block here, each one of these runs to one of the 3 turn offs down there. The blue ones run to the turn offs of these 3, and the red turn offs run to these. And so that's it. That's essentially, you can think of it as kind of groups of ideas. This is what turns on the furnaces. This is what turns off the furnaces. These 2 over here are just power blocks to provide power to each of these things. So this one is associated with the turn on, this one's associated with the turn off, and that's it. And so once you have that and you set your filters, now you've got a system where these 3 conveyors will turn these on if they can pass things from here, And these three conveyors will turn everything off if they can no longer take anything out of them, you know, and put them into here. And that's how it auto turns auto off, you know, on and off. Now, again, you don't actually have to do that if you don't care that they're just running all the time or whatever. You're not saving any power by having them turn on and off. It's just kind of cool, you know, why not? So that's pretty much it for that. And again, I'll just throw, let's see, I'll just throw all these in there, why not? I'm just gonna dump these in there. So you'll see these three they're gonna all turn on. These three up here, see how those are now green on both sides. These are now off on the one side because these three conveyors are now conveying. They're now sending out a filter pass, but we don't use the filter pass on these. We're only using the filter fail, which is now 0 because they are passing. So they're no longer trying to turn these off because they are currently able to pass. Whereas over here, if you look in here, we still have some. So right now, the starts are now off. The turn on one is now off because we don't have any left, but they're already running. And since the filter pass is the only one we're using, you know, the filter fail is empty. It's sending out a volt saying like, hey, I'm not seeing anything, but we don't care because we purposely left that off. So the filter pass is now 0. These have now you know, broken the AND switch's requirements. The B side is no longer active, so we're not passing any voltage, but we don't care about that because they're already running. So these don't act like momentary switches where, let's say this loses power to the turn on. It doesn't turn off because that loses power. It requires a reference volt to come to the turn off one, if I can get it to light up there, the turn off one there, in order to turn it off. So it's volt on and volt off. So once you have them running, you can't turn them off by taking power away from the turn on, is I guess what I'm trying to get at here. So as these things are running, again, we're sending stuff into this dump box, which I guess doesn't have to be a big dump box, but what if you fill up, I guess, I don't know. And it's gonna just keep on filling this up as it goes. And so each one of these furnaces is just constantly pulling things in, constantly cooking them down. And you know, this is a perfect opportunity to see how it is the electrical system works on this. So going back over here, just, you know, this one here, this 27 out, this first branch, I did a branch out of 27 for this purple line, and that runs to this. I did 27 because I need 13 and 13. You can use a splitter here, but because it's the same, I mean, it doesn't really matter. It's just smaller and, you know, less obtrusive than those, I guess. But it's 13 and 13, so that's 26. So 27 if you include the branches requirement. So I have that one setting out there. Again, this blue one here, this blue output here is the one that's running to this block here, and that's just powering each and all the furnaces. So that one's set to 31. The light blue one is all of the conveyors, you know, 1, 2, 3, 4, 5, 6, all daisy chained together. So that's set to 6. And then this last one here, the green one, is the 2. That's just the one that's powering these two. Again, I just have these set to pull one of the two things out, just as a sort of very simple example of a automatic sorting, if that's something you care about, to each of these boxes. And so if we go and look in these furnaces, we got 15 left there, 28 there. Because of the way they pull things in, they sort of they scan every so often if there's something to pull. Your furnaces will start and end at different times. So these 3 are now empty, and so this has turned off, and these 3 are still running. We're almost done. These are going to turn off shortly. These are going to turn off shortly. So they're all going to turn off here in a minute. But so one of the reasons I did that was because I liked the idea of having, instead of all 9 coming on at once, I like the idea of having groups of them that I could say set to, well, I really want to focus on something here. You know, maybe I want to do something else here and something else here. And that way you're not limited to just, you know, all or nothing. But it is expandable. It is, you know, I guess despandable. It's not a word, but you can make this bigger or smaller depending on how much stuff you want to do. So for smaller bases, you could cut this down to just a single furnace and just omit all the combiners and splitters. It would just be a lot easier. The power requirement would only be reduced by the furnace, so you'd lose 6. You'd save, 6 times 3, 18, if you were to just cut this down to 3 furnaces total. But yeah, and that, folks, is just about it. If you have any questions or comments, you can leave them below. Otherwise, you can get me on my Discord. See you later.